All right, so section 4.4 is all about trig functions, but of any angles. So it doesn't have to just be right angles like it was in 4.3. So we can do certain things with things that are just non-right angles, or so any angle. This list is in your textbook for you to reference, but I'm going to go ahead and write this down for you too. So the sine of the angle is equal to y divided by r, and I'll explain what r is in just a moment. The cosine of an angle is equal to x divided by r. Tangent of an angle is equal to y divided by x. And cotangent of an angle is equal to x divided by y. Secant is equal to r divided by x. And cosecant of the angle is equal to r divided by y. Okay. And so just to kind of show you what I mean by r here, so we've already talked about and established some relationships with trig functions. All right, let's say that we have an angle. So let's say that this line, we start on the horizontal axis or the x-axis, and we take this and we slide this all the way around, right? So it ends up over here. Okay. Well, the angle theta is generated by sliding that side over, right? So that gives us our theta. This up here will result in an x and y coordinate, and this line has a length of r. Okay? So r is the length of the line, so that is where r comes into play. Okay. All right, and so then another thing that I want to establish here is what's called the reference angle. The reference angle is the angle, it's the acute angle and we will call it theta prime, that is formed by the terminal side of theta and the x-axis or the horizontal axis. Okay. All right. So, just kind of to replicate that drawing there, we have theta as our angle here. All right. The reference angle is the angle that it would take to move that line onto the horizontal axis, okay? So it is the difference between theta and the angle that it would take to get it to the horizontal axis. Okay, so let me show you an example of that. Let's do two examples. All right, so we'll say example one. Let's say that we have this angle here, and we'll say that theta is equal to 120 degrees. Okay, so our angle here is 120 degrees. All right, well then our goal is to figure out what theta prime is, because it's the angle that it would take to make that to the difference between the horizontal axis and our angle theta. Okay, well, a straight line or a flat line has a measure of 180 degrees. Theta has a measure of 120 degrees. So we just subtract that off to find that theta prime is equal to 60 degrees. Okay? So it is the angle that would be required to move that line on to the horizontal line. Okay? But let's do another example to where maybe it's not 180 degrees, and so let me show you that. So let's say that we have theta. So we took, so we have our line here, and we went all the way around to here. Okay. So we'll say that theta is equal to 280 degrees. All right. So theta takes care of this part. Now we want to find the smaller acute angle, theta prime. All right, well here to go full circle, it would be 360 degrees. So 360 degrees minus our measure of theta of 280 degrees will give us theta prime. Okay, and of course that is 80 degrees. Okay? So it would take 80 degrees to move this line back to the horizontal axis. So we always want to be moving as close as possible to the horizontal axis. And so your options are going to be 180 degrees or 360 degrees. Okay. All right. So now let's recap quadrants, just in case anybody may have forgotten. So we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay. So let's answer a question. This is similar to a homework question. If we wanted to say that the sine of the angle is positive, but the cosine of the angle is negative, then what quadrant would that lie in? Okay, so that's our goal to answer that question. All right. From the list that I put on the first slide, we have the sine of theta is y over r. Cosine of theta is x over r. Okay. One thing to make a note of, r is a distance, so r is always positive. Okay. So r is always positive because it is a distance, so it can never be negative. All right. So for the sine of theta to be positive, then, so for the sine of theta to be positive, that would mean that y would be positive. Okay? So sine always corresponds to the y coordinate. Then for cosine of the angle to be negative, that would mean that x would have to be negative. Okay? So then what quadrant would y be positive and x be negative? Okay? Quadrant 1, I'm positive, positive. Quadrant 2, my x coordinate is negative, but my y coordinate is positive. Quadrant 3, I'm negative in my x direction and y direction. And quadrant 4, I am positive in my x direction, but negative in my y direction. So here we are looking for a positive y, but a negative x, which happens in quadrant 2. Okay? So just by knowing the value of the sine of the angle and cosine of the angle, I can then find out what quadrant that lies in. Okay. All right, and the last example problem that I want to discuss is, what if we are given something like that the tangent of theta is equal to negative 24 over 7. Okay, and we're going to make a constraint to limit our possibilities and say that the sine of theta will be positive, meaning y is positive. Okay? And our goal is to find out, well, what is the value of the sine of theta? And what's the value of the cosine of theta? Knowing that the tangent of theta is equal to negative 24/7. Okay? So just from that first page, the tangent of theta is equal to y over x. Okay? All right, so what does that mean? Well, sine, I need to know an r value, but I have not found that yet. I have to find an r value to be able to figure out what sine, cosine is, secant, cosecant, and so on. Well, how do I do that? Well, fortunately for us, we do have the Pythagorean theorem. All right, so I know that my y is positive. Okay, well, y is 24. So I'm going to say 24 squared plus, we'll say negative 7 squared will be equal to our r squared. Okay. All right, so just using the Pythagorean theorem, I find that r is equal to the square root of 24 squared plus negative 7 squared. So r is equal to 25. Because the radius r is equal to the square root of x squared plus y squared. Okay, so you can find the radius of any circle or any angle that because of r being the square root of x squared plus y squared. Okay, so now that I know that my r is 25, then my sine of theta is y over r, right? Remember, so from that first list, sine is y over r. Well, I know that my y is positive. 25, of course, is positive. So therefore, the sine of this angle is 24/25. Okay. However, notice that our tangent is negative, right? So that means that we have a negative x value. All right, so the cosine of the angle is x over r. So cosine of the angle is x over r. Well, I know that my x is negative 7 and my r is 25. Okay, and you can use this same thought process, which one of your homework questions includes this, to where you can find secant, cosecant, cotangent, and so on any of our trig identities based on just knowing what your x and y values are. Okay? So this concludes section 4.4. If you do have any questions, please feel free to email me, and have a great rest of your day.